Hi, I'm Rob Telson, Vice President of Sales and Marketing at BrainChip. Thank you for joining us today here at the AI Hardware Summit. Today, we're going to talk about intelligent AI everywhere and our Akida Neuromorphic processor. Our mission is unlocking the future of AI. And with Akida, we feel very strongly that you'll feel the same way that we can do that. Let's talk about the problem that exists today and is continuing to get worse. We're talking about the amount of IoT-based devices that exist, or also edge-based devices. All of these devices are taking their data and driving it to the cloud. They drive it to the cloud where that data is then processed through the data center, an edge data closet, a server, and so on. Well, what's happening is by 2025, we're expecting 90 zettabytes of data to be driven from these edge-based devices to the cloud. And in doing so, all of us with our edge-based devices, whether it be your phones, your watches, your cars, medical devices, or things in your home, whatever it is, or even industrial applications, they're going to be competing for bandwidth, and they're going to be competing for the same resources. In other words, things are going to start slowing down, almost like a traffic jam on a freeway. The other thing that's going to happen is we're going to open ourselves up to more privacy and security threats. And that's a massive issue because the more data that's going off the device to the cloud, the more vulnerable one is. And then there's going to be this demand for personalization or autonomous learning on the device at the edge. We're all going to want things that are unique to what our preferences are. And lastly, you have latency challenges or speed, how fast we're going to be able to communicate and get data back from the cloud to the cloud and so on. With Akida, we're solving all those problems because we're doing everything on the device without the dependency on the cloud. And we're doing it in a very small power envelope and processing at competitive performance environments. So more about BrainChip. We were founded in 2013. We have over 15 years of fundamental AI architecture research and focus on the neuromorphic architecture and implementing that into a commercialized product. We have over 55 data science engineers, hardware engineers, software engineers, with the 14 patents on our technology. We're publicly traded on the Australian exchange as well as the over-the-counter exchange here in the US. And our customer engagements at this time have really been focused on early access engagements where we're leveraging and proving out the technology, as well as proof of concept engagements and IP licensees. And we're really focused on 4 areas, which are smart city, smart health, smart home, and smart transportation. So when we think of intelligent AI everywhere, we start with intelligent AI at the edge. And edge AI is not running inference at the edge of the cloud. That's still a data center. Edge AI should start at the sensor and make it smart. Smart sensors will send metadata after the analysis. And that edge AI computing requirements require a different solution. There's this balance of an extremely low power budget with real-time performance, a demand for that, and operating within severe constraints on memory capacity and bandwidth, and offloading tasks from the limited CPU computing power. Most importantly, though, it's really real-time learning and rapid retraining at the edge. So how does BrainChip's Akida technology address this? We overcome all these edge AI challenges that are becoming massive blockers as we move forward by adopting a neuromorphic architecture. And with that neuromorphic architecture, what that means is we're processing event-based activity only, consuming very little power only when an event occurs. And we do that by running the AI inference by running in the event domain. And our reduced memory requirements with 1, 2, or 4 bits for weights and activations, and the on-chip learning in the event domain using our proprietary algorithms. So let me put this in simplistic terms for you. You have this image over here with a lot of activity on it. It's really meant to say, where's Waldo? So your traditional AI processors have to process everything in this image until they find Waldo. And with Akida and its neuromorphic architecture, we're only focusing on the event at hand, and the event at hand is Waldo. So consuming very little power, sometimes magnitudes less, and being efficient from a performance standpoint, we get to Waldo a lot quicker with a little less power or a lot less power using our architecture. And if I put this in another way, a human brain is consuming about 20 watts when it's processing stuff. The neuromorphic chip is processing in microwatts to milliwatts, and your traditional AI processor, hundreds of watts. And from a performance standpoint, the human brain's processing in milliseconds, while Akida is processing in nanoseconds, and your traditional AI processor is in milliseconds. But what we like to focus on is what you see in this graphic with Robot Ken. We focus on 5 sensor modalities. You have your visual or image sensing, you have your auditory, you have your olfactory or your e-nose sensing, you have your gustatory or your taste, and you have somatosensory or your tactile sensing, your vibration, your touch. Those are the areas in which we focus on. We do all of this on the device, and we can process all of these on one device. That's what makes BrainChip exciting. So let's look at this. So I talked about device personalization. I talked about customization. So let's take a look at edge-based learning with facial recognition. And then I'm going to show you another demo with visual wake word, as well as facial identification and recognition. So we start with just edge-based learning. And what we're going to do here is we're actually going to learn Aaron's image on the fly. He's not in any data set or a network, whatever you want to call it. It's Aaron right here, one shot taken. Okay. And then we're going to add in Anil. So you'll notice it recognizes Rob. So I'm already in the system. And then we teach it Anil. Now Aaron's going to come back in, and you're going to see that Akida immediately recognizes that it's Aaron. Oh, he goes back out, he comes back in. Still Aaron. And here comes Rob. Rob's going to come in, already in the system. Akida recognizes me. I'm going to bounce around a little bit, try to trick it. It tracks where I go. And here comes Anil. And Neil's really going to do the same thing. He's going to turn his face to the side a little bit. He wants to see, does Akida follow me where I go? And it does. It works the way it should. Yeah. And finally, Chris is already in the system. He's going to come in and make sure Akida recognizes him as well. This is pretty cool, but let's see how this works in a real-time environment. And so what we've done here is we have Akida running in 2 different environments. We have what's called visual wake on one side in the blue screen, and that will show you that it recognizes a person that enters the room. And then you have face recognition on the other side, where it will show you who that person is. So in this first demo, we have Aaron coming out of an elevator. It recognizes him as he enters, and it recognizes who he is. In this second demo, we have a group of people that it's going to recognize. Here comes Aaron. Here comes Nikunj. Rick. Tabitha. Hussein. And Rob. So how do we do this? And how do we do it on the chip without having to do a lot of reprogramming, getting a lot of data scientists involved, creating a new network and so on? Well, we have our neuromorphic design principles, and they're made up of 4 principles. The first one is distributed computation. So we're talking about computation spread across many cores. Neural processing units are what you'll hear me reference as NPUs. And each NPU has its own dedicated computational engine and memory, which reduces the data movement. We also have our event-based processing. Again, as I mentioned in the Where's Waldo image, we're focused on non-zero activation map values, and they're represented as multi-bit events, 1 to 4-bit events. And the NPUs only perform computational events and not activation maps. And our event-based communication, these NPUs communicate by sending events to each other over a mesh network without the host CPU intervention. And that neural network connectivity is configurable in the field. And finally, what I get excited about is the event-based learning. Akida implements an on-chip learning algorithm. That's really important because we don't have to communicate with the cloud, and we can add new images, new voices, new vibrations, new tastes, new smells without communicating to the cloud. And so that reduces your engineering requirements, your development requirements, and provides you with customization on the device. So our processor as it exists today, I like to look at the gray box because that's our neuron fabric. That's really what makes us unique. But the processor has a ton of interfaces on it today. And you'll see that we have our processor in this image on the board below. We have our production parts, and we're actively engaging and willing and ready to support anyone interested in acquiring our processors. And then we also license our IP. And again, what makes this unique is that we do offer an IP. It's configurable by the number of nodes. It's basically technology independent, and it's standard CMOS and standard SRAM, programmable data to event converter, as well as the event-based NPU engines running on a single clock, configurable on-chip SRAM memory. And the on-chip communication, as I've highlighted before, it communicates through the mesh network and with the on-chip learning in the event domain. And the cool thing is, it's standard IP. Its deliverables include the RTL, the development tools, the test suites, the documentation, and that's all based off of our software development kit, what we call MetaTF, and that's our framework, structure, and workflow, which saves a tremendous amount of time. There's no need to learn a new framework with MetaTF. You can start using it today, as a matter of fact, and it's based off of TensorFlow. So you're using the TensorFlow models that you've developed, and I like to look at the bright blue boxes, and so that's what you're doing today. The darker blue, those two dark blue boxes, is where you incorporate MetaTF. So you do your traditional CNN design in TensorFlow, you do your training in TensorFlow, and you do your quantization or your CNN to SNN quantization. And that's done in MetaTF. It's all automated. You can do your fine tuning if you want to in TensorFlow, and then back to the CNN to SNN conversion tool. And again, that's automated. And then you do the deployment into Akida. It's a simple environment leveraging standard CNN models that you've designed in TensorFlow. So the types of models that we have applications with today in our software development kit, there's image classification and person detection, there's face detection and classification, there's object detection, there's keyword spotting, there's DVS image classification, as well as 3D point cloud and LiDAR classification. So let's do another demo. This one's really cool. This is, to me, is exciting because we're talking about keyword spotting, and we're talking about it where we have people that are going to be referencing Hey Akida, and they're not in any type of data set or anything to that extent. So we're talking about two people, which I'll do the demo right now, and take a look at this.
Hey Akida. Hello. Hey Akida. Hello.
Hey Akida.
Hi.
Hey Akida.
Who is this?
That is done without these voices in a data set. Now, these voices are in a data set, and here we have Akida recognizing these voices and responding differently.
Akida.
Hi Todd.
Hey Akida.
Hi Todd.
Hey Akida.
Hi Rob.
Hey Akida.
Hi Rob.
Yeah, so in this demo, as you can see, Akida recognized who we were and then responded with a greeting back to us. And again, these are two just basic demonstrations where we're referencing Hey Akida, one with new voices and one with a bit of device personalization.
Hey.
So where are we with our business models? We have 4 business models, and we're licensing IP today. We have our production chips, and they're available also in whatever volume you're looking for. We are in the process of taking pre-orders on our development systems, and we have 2 development systems available. One is an x86 PC shuttle, and then one is going to be an ARM-based Raspberry Pi development kit. And we're taking orders on those today. And then in the future, we'll have board modules available as well. So it's exciting times for us, and you can request your development kits by going to sales@brainchip.com. And in a short while, we'll have our website up, so you can just purchase the development kits from our website as well. Let's do another demo. This one is really cool. This is the edge-based learning. We're going to do some image classification here and learning of devices or images, and then we're going to do some of this recognition in very high performance environment. So one of my favorite demos that we've done, this is a beer bottle demo. Again, these images they're not in a network or the data set. They are different. We're adding them in as we go. So what we just added in there was a Corona Premier bottle. And here we're adding in a Rolling Rock beer bottle. And you can see that we're doing this, what's called one shot. And that's important to recognize in how we do this. This is a birch beer that we're doing with one shot. And now we'll come back in and we'll introduce, we're going to add one more. I'm sorry. We're trying to trick Akida here by adding in a Corona Light bottle, because Corona Premier and Corona Light are very, very similar. And we wanted to see if it would recognize the differences. So here's Rolling Rock, it recognized that. And then we add in birch beer. It recognizes Corona Premier. And let's put in Corona Light. And you'll notice when we put in Corona Light, it's toggling back and forth. You know what? Let's add another shot. This is how simple it is to add additional shots while you're learning on the fly. Okay, so now we add in another shot. Now it recognizes Corona Light. Think about that when you want to customize your own devices at home in the future. How easy is it? This is Corona Premier. It recognizes again. And now we notice very quickly it recognizes Corona Light because we added that second shot in. So here's a human eye. We're out of focus. Is it Corona Premier? Is it Corona Light? It's Corona Premier. And Akida recognizes it's Corona Premier. So let's move on to something more complex. And this is a high-speed video of that we've done here. We've trained in 4 images. One is the pit crew, as you see, with one shot. We also did the racetrack with multiple shots. We did the Formula One race car with multiple shots and the motorcycle with multiple shots. But I want you to notice how fast things are moving around it. So it's not a stationary background, and the images are not in the center of the frame. They're constantly moving. So you notice they recognize the racetrack, the Formula One race car, the pit crew. Here comes the race car back into image. You'll see how blurry it is because it's moving so fast, and Akida recognizes it. Here comes the motorcycle, again, moving at very high speed. Recognize the image as it's moving through. Take a look at this. Look how blurry that is. I pause this real quickly because I need you guys to understand this is a very complex image. It's not a still frame, and Akida is recognizing it as it moves through the video. Here comes a motorcycle back into frame. It tracks it very well. And at a higher speed, here comes the Formula One race car. And nothing would be more satisfying than seeing Robot Ken very excited. So with that, I just want to highlight, this is our mission. Our mission is we don't make the sensors, but we are going to make them extremely smart and extremely intelligent. We don't add complexity, we're eliminating the complexity. We don't want to waste time. We need you to save time. And we solve these tough edge AI problems. These are problems that others do not solve or cannot solve. So by leveraging our one-shot learning, our localized processing without having to go to the cloud, and working in an ultra-low power environment, that's Akida. So don't miss the bus and join us. Intelligent AI everywhere. This is our mission. please go to our website at www.brainchip.com or www.brainchip.ai. You can also contact us at sales@brainchip.com. And we'll be demonstrating here the next few days at this event. And we look forward to speaking to you at the event or in another format. Thank you